Okay, so this next section, 3.3, solving equations with variables on both sides. So we're going to still use our notes from the beginning of this section to guide us through this. So if we go back a few sections in our notes, solving multi-step, simplify each side of the equation, we're basically starting at step 1 now. Now, they're not always going to have fractions, so we don't always have to clear the fractions. We won't always have to distribute. We won't always have to combine like terms. But step 2, where it's worded as isolate constants on one side and variables on the other side, meaning constant terms and variable terms on each side, is kind of what we need to focus on in this one. And then once you understand that, then treating each side of the equation as its own kind of separate expression, simplifying those first and then applying these two steps, will guide you through how to do these problems. All right, so it doesn't happen very often, but these are two types of things that could happen, either an identity or no solution. 9 times out of 10, you're going to find a value for a variable that makes the equation true. And that's what we've been doing this whole time. But every once in a while, you have ones that come out as an identity. So when you're simplifying, it comes out as x equals x, or 0 equals 0, or 2x equals 2x, something like that, where it's obvious that it's the same on either side of the equal sign. So no matter what you put in for the variable, it would be true. So it's called an identity. Basically, all real numbers would be solutions to that problem. A no solution would come if you, as you simplify these problems, and there's a couple examples that I show you, that if it comes out to something like this, like 6 equals 0, where basically the variable terms end up equaling 0 when you simplify it, and you have like a number that doesn't make sense. So that would be, there would be no solution that would make that true. And when we get into graphing, you'll see where that comes into play. Okay, so referencing these notes, if you have those out, you can kind of follow along with that. The one piece is that we need to get constant terms on one side of the equation and variable terms on the other side. So kind of in a reverse of what we've been doing the last couple times, I look at these. Now I see a variable on the left side and a variable term on the right side of the parenthesis. So I need to make sure that those variables are on one side and my constants, meaning my whole numbers, are on the opposite side. So in this case, I would take this d, and you're used to multiplying or dividing the d to get it to equal 1. But since I want to get rid of the term altogether, I'm going to subtract the d. So I'm basically doing the opposite. So I'm taking a positive 1d, minusing 1d, and making it equal 0. So I have to do that on the other side as well. So it's that same rule applies, that whatever you do on one side, you have to do on the other. So now when I am simplifying this, I bring down my 4. The d's become 0. And then I have a negative 6 minus 1, right? Because we have, that is considered a 1 right there. So negative 6 minus 1 gives us negative 7, so that would be negative 7d. All right, so now I'm at here. It's a single step problem. I have to make this d a positive 1, so I would divide that by negative 7. So my answer is d equals, now you can leave this as 4 over negative 7. You can leave it as a fraction, or if you want to change it to a decimal, you can. So 4 divided by negative 7 gives me negative 0.57. I'll round that to the 100th. So that's one example. So when we have a d on either side, or a variable on either side. Example D shows that we have a variable term, a constant, so we have a 7k as our variable term, we have a negative 4 as our constant, we have a 5k, and then we have a positive 16. So we have 4 terms, 2 on each side. Now I need to get what the variable terms on one side and the constants on the other. And the way we do that is we add or subtract to make them equal 0. All right, so if I'm looking at this, I know you will come up with your own personal preference on how you do it. You might want to go from left to right. You might want to work within the equation. That's up to you. What I like to do is I like to keep my variables positive. So if I know I'm going to subtract a 5k here from both sides, 7 minus 5 would equal 2. So I know I'll be dealing with a positive k. But if you're just going left to right, you might subtract a 7k from this side, giving you a negative 2 on this side. Or you might see this negative 4 and say, hey, I want to add that to that side. It's either wherever you start, as long as you're keeping your rules on which numbers you're adding or subtracting and doing it to the same to the either side, you'll be okay. So for a lot of students, this negative 4 is going to stand out. So we need to either get the negative 4 to equal 0 and then move it over here, or the 16 over here, or the k's or the 5's, either way. So I'm going to start with this 4. I'm going to add 4 to this side. I'm going to add 4 to this side. Now notice that I'm lining it up with the 16 because I cannot combine it with that 5k. It's not a like term, so we can't do that. All right, so as I simplify the left side, I have a 7k, and then I have that 4 becomes 0, so that's just gone. I have my 5k, and then I have my 16 plus 4, which would be positive 20. All right, so now I have basically kind of what I have over here in example A. This 5k now and 20 are on the same side and have a k over here. So I want to get this k out of this side and adjust the left side. So how am I going to do that? I'm going to make that 5k a 0 by subtracting 5k. So 7k minus 5k is going to give me 2k equals 20. And then I'm at my single step problem where I can divide by 2 to get 1k by itself. And I have now k equals 20 divided by 2 is 10. And then if I substitute this back into the problem, 7 times k minus 4 equals 5 times k, or k plus 16, and I put 10 in for both of those. So this will be 70 minus 4. I'm working up now. 50 plus 16. 50 plus 16 is 66. 70 minus 4 is also 66. So those equal each other. All right, so that's how it works. We're finding one solution that works to solve both of those problems. Now here are the kind of those outlier examples that I talked about right at the beginning where we talked about identity and no solution. I'm just going to do these problems so you can see what they look like. So over here, similarly to here, I got to get constants on one side, variables on the other side. So some of you guys might start with the negative 1 and just add it. And I'm going to add it to the 9. So I'm going to write my equal sign underneath. So I have 5n on this side. And then over here I have 10 plus 5n. All right, now from this point, I have a constant and a variable, so I want to get rid of this variable over onto this side, so I'm going to subtract 5n from both sides. So you'll basically be adding and subtracting until your very last step where you're either going to multiply or divide. So over here I have 10 equals, and then 5n minus 5n is 0. So this would be an example of no solution. If it comes down to where the variable terms cancel out and the two numbers on either side don't match up, it would be no solution. Over here is another example. So here I have to, going through the first step, I'm combining like terms on this side. So I have 9 plus 5x. I'm not doing anything to this side. 7x and a negative 2x would give me a positive 5x and a positive 9. So if you can see, I have a 5x on this side, I have a 9 on this side. So they're basically the same terms on either side. So right here, you can, if you notice that, you can say it's an identity. But if not, let's keep going. Let's say I subtract 9 from both sides. So that would give me 5x equals 5x. Again, here you can see that as well, where it's the same on both sides. So if it comes down to that, it's an identity or all real numbers. So infinite amount of solutions, however you want to say it. Okay, so I want to do one more example. All right, so this is your basic examples of, if I have a constant and a variable term on either side. This one I have just variable terms on either side and one constant. Here I had to combine like terms before I started that. So over on this example, which is not in your notes, but we're going to test this one out. So this kind of brings it all together. This will be kind of the higher level type problems that you would have to solve involving distributive property, combining like terms, variables on both sides of the equation. So I'm going to walk through this problem. All right, so if I'm looking at this, and again, try to look at each individual side by itself. So this side is already simplified. There's nothing we can do. But here, we have to distribute, and then we'll be combining like terms. So if we go back to our notes, this is why when I write the notes, simplify each side of the equation. And this is optional, clearing the fractions, whatever. Distribute, combine like terms, that's why it's a B and a C in there. Then we're going to isolate constants on one side, variables on the other, and then multiply or divide to get the variable term by itself. So this example encompasses all of that. So I'm going to first distribute, and again, if you need to use the box method to distribute, go ahead and do that. If you're comfortable without it, you can do that as well. I'll just continue to do it just so you guys can visually see it. So that's negative 4x, and that would be negative 10. So I'm going to rewrite this as negative 4x, negative 10. So that's this part taken care of. I have a negative 4x still there. On the other side, I have a 6x, and I have a negative 7. It's okay to space these out so you can see the actual terms that you're dealing with. All right. Now on this side, I still have to combine like terms. If you can see, the two like terms that are alike would be the two negative 4x's. So negative 4 minus 4. And again, use your calculator if you're with their integer rules. So negative 4 minus 4, or negative 4 plus a negative 4, it's the same thing. Negative 8x. Then I still have my negative 10 equals 6x, negative 7. And now we're at the point where we have variable terms on both sides and constants. So I need to figure out which side I want to put the terms at. So I am going to add 8x. Oops. Add 8x to get rid of it on this side. So if I add 8x, I know I'm going to be adding 7 for my next step. As you get more comfortable, you might elect to do that step right now, because then we're just saving some paper. But I don't expect you to do that, as we're just learning this skill. So as I go through, these are canceled out. Negative 10 plus 7 would be negative 3 equals 6 plus 8. So that would give me 14x. And then obviously negative 7 and positive 7 would be 0. Here, now I have to divide to get the x to be 1. Divide by 14. So my answer would be x equals negative 3 over 14. If you want to change that to a decimal, so 3 divided by 14, you could do that as well, negative 2.1, and then it goes on. So negative 2 or 0.21, go 4, whatever. I like just leaving it as a fraction. So essentially this is your final answer, but just show that it equals x. Again, if we're going back here to show the problem without that, using that double step, you would just take the extra step in there. So this would be negative 8x right here, because that's where we finished off. So if I add 8x, or I could subtract 6x if I want, it doesn't matter. So then I would have negative 10 equals 14x minus 7, and then you would just be adding that step as a second step. So that would be negative 3 equals 14x, and then we get to our final step. Negative 3 over 14 equals x. All right. So that is that skill kind of in a nutshell. Go ahead and rewatch some of this if it's not making sense, to help clarify any questions.